Okay, let's talk about improper integrals. An integral is improper if the function approaches infinity or negative infinity for one or more points on the domain of the integration. So let's say we have like this random integral here. If any points from this point to this point causes the function to approach infinity or negative infinity, we consider the integral improper. Or if the integral has the form of any of these three, where the bounds are a through infinity, negative infinity through b, or negative infinity to infinity of any function, where a and b are real numbers, then it is also improper. And to solve integrals in this format, we would take the function, which is from a through infinity, and f of x dx, the function, and we would set it equal to the limit of as b approaches infinity, and replace the upper bound with just b, but we know that it approaches infinity. And then we would integrate the function regularly and apply the bounds. And let's do some practice problems with these. One other thing we need to consider when we make this definition, where this integral is equal to this limit, is for the improper integral to exist, the function being integrated, f of x, must approach 0 as x approaches infinity, so that we are actually able to find the definite integral, and it's not just infinity, because if the function doesn't approach 0, then it'll just diverge. Question 1, we have the integral of 1 over x cubed dx with the bounds 1 through infinity. So first we know that this function will approach 0 as x approaches infinity. So now we can use the limit definition. So the integral of 1 through infinity, 1 over x cubed dx is equal to the limit as b approaches infinity for the bounds 1 through b, and the function. And now we just have to solve this integral. So 1 over x cubed is just x to the negative 3, so this is equivalent to the limit as b approaches infinity, negative 1 over 2x squared with the bounds b and 1. And if we apply the bounds, this is going to be the limit as b approaches infinity, and this is negative 1 over 2b squared plus 1 over 2, because when we do minus negative 1, 2, it'll just be 1 over 2. So now if we apply, or if we say that b approaches infinity into this function, this is going to be negative 1 over infinity. And obviously you can't just do 1 over infinity, but when you have a value that approaches infinity and it's in the denominator, we say that's 0. We say that's equivalent to 0. So this is just going to be 0, and this is just going to be 1 over 2. So the whole thing is equal to 1 over 2. Question 2, we have the function x squared dx with the integral and the bounds 1 through infinity. And before we apply the limit definition, we know that for the improper integral to exist, f of x must approach 0 when x approaches infinity. But in this case, when x approaches infinity, f of x will also approach infinity. And since it doesn't approach 0, this value, we can just say it does not exist, and that's the final answer. Question 3, we have the function 1 over x squared minus 1 over x cubed, and the bounds are 3 to infinity. And this function will approach infinity when x approaches, or no, the function will approach 0 when the x approaches infinity. So let's use the limit definition. So 3 to infinity, and let's just define this as f(x), it's fine. And the limit as b approaches infinity for 3 to b of the function. And now we need to just integrate this, and it's just going to be simple power rule. actually, this is just going to be, we can just integrate it straight away. So negative 1 over x plus 1 over 2x squared with the bounds b and 3. And now let's apply it. So this is going to be the limit as b approaches infinity. And it'll be negative 1 over b plus 1 over 2b squared minus negative 1 over 3 plus 1 over 18. And then now all we have to do is just simplify this. So this is going to equal negative 1 over b plus 1 over 2b squared. And if you simplify this part right here, this will just be plus 5 over 18. And as we see, b is in the denominator for these two terms, and b approaches infinity. So this is, both of these are just going to be 0. And all we're left with is this 5 over 18. So that's the final answer.